All right, you are welcome again. Today, we want to discuss Fourier transform. Okay? And then under Fourier's transform, let's take a look at this question. Find the Fourier transform of the function f of x is equal to e raised to the power of minus x squared all over 2. Okay? Yes, we are asked to find the Fourier transform of this function. All right, let's go. By definition of Fourier transform, we say that the Fourier transform of f of x, which is going to give us the Fourier of omega, is equal to 1 all over square root of 2 pi, the integral from negative infinity to infinity, positive infinity, f of x, e raised to the power of minus I omega x dx. Okay, so this is the formula, or this is the definition for Fourier transform. Now, in this case now, our f of x is given to be e raised to the power of minus x squared all over 2. So let's write it properly. So that means we're going to say that the Fourier of the omega, okay, is going to give us 1 all over square root of 2 pi, the integral from negative infinity to positive infinity, e raised to the power of minus x squared all over 2, multiplied by e raised to the power of minus I omega x dx. Okay, so let's apply the law of indices and add the exponents. Okay, so adding the exponents, we are going to have 1 all over square root of 2 pi, the integral from negative infinity to positive infinity, e raised to the power of minus x squared all over 2 minus I omega x dx. Okay, yes. Now, pay attention, please. Let's work on the exponents. The major work that we want to do on this exponent is this. In the first part, we have x, which is our variable. And then also in the second part, we also have x. So what we want to do is, we want to separate this variable in such a way that x will be in one side alone, and there will be another part that doesn't have this variable. So we can call that one our constant. Then we take it behind the integral sign. So that is what we want to do. Now pay attention. The exponent says minus x squared all over 2 minus I omega x, right? Yes. Now let's clear the fraction. So when we clear this fraction, we are going to have minus x squared minus 2I omega x, let's say, is equal to 0. Now, looking at this very well now, you see that, okay, let's say that this is equation 2, right? And then the one we have above is equation 1. Now, looking at this equation 2 very well, you see that is a quadratic equation, right? Yes. So for us to solve this quadratic equation, I want us to employ the formula of completing the square. All right. Employing the method of completing the square, what does this method say? First of all, let's take a look at the coefficient of x. The coefficient of x, let's pick it. The coefficient of x is minus 2I omega. All right? Now, take the half of it. So for us to take the half of it, that means we multiply it by half. So multiplying by half, what do we have? We have minus 2I omega all over 2, right? Good. Now, square it. Now, when you square, we are going to have minus 2I omega all over 2 in bracket squared. Okay? Now, let's simplify. Inside this bracket, we have 2I omega all over 2. So 2 we cancel 2 within inside, right? So we are going to be left with minus I omega in bracket squared. So the half of the coefficient of x squared, add it to both sides of this equation. You know, in this equation 2, it have two sides, right? The right hand side is 0, while the left hand side is minus x squared minus 2I omega x, right? Good. Add it to both sides. So, when we add it to both sides, we are going to have minus x squared minus 2I omega x minus I omega in bracket squared equal to, in the right hand side, when we add, we're going to have minus I omega in bracket squared. Okay, good. Now look at this left hand side. In the left hand side, we're having negative throughout. Let's factor out this negative. So when we factor out the negative, we are going to have minus open bracket x squared plus 2I omega x plus I omega in bracket squared equal to, when you open this bracket in the right hand side, I is going to give you squared, right? Good. And then we have omega squared also. So I squared is minus 1. So minus 1 multiplied by the negative outside. So we are going to have omega squared, right? Good. Now let's go. Recall that where you have x squared plus 2xy plus y squared is the same as x plus y in bracket squared. Hello. When you have x squared plus 2xy plus y squared is the same as x plus y in bracket squared. So when you simplify the right hand side, you are going to get the left hand side, right? Good. Now look at this we have now and what we just obtained. What we just obtained, we have x squared plus 2I omega x plus I omega in bracket squared. You can see that this I omega is the same as y that we have here, right? Good. So that means using this simple logic now, we can say that we have minus open bracket x plus I omega in bracket squared. Yes. So we see here that this minus open bracket x squared plus 2I omega x plus I omega in bracket squared is the same as minus open bracket x plus I omega in bracket squared. Please, I want you to try open this bracket, this second one, okay, and see if it will give you what we have. All right. So we say is equal to omega squared. So in this case, I want us to do something. All right. I want it to be in fraction. Yes. So it's either you multiply both sides by half or you divide both sides by 2. These two sides, they say they are equal. So when you multiply by any positive number, it's still going to be equal. Okay. When you divide it by any positive number, it's still going to be what? Equal. All right. So in this case now, we can multiply by half. It will still be the same. We can divide it by 2. It will still be the same, right? Good. So here, let's divide by 2. So when we do so, we are going to have minus x plus I omega in bracket squared all over 2 is equal to omega squared all over 2. All right? Good. Now, pay attention to the left-hand side. In the left-hand side, we have the denominator 2. So now, this 2 is the same thing as the square root of 2 in bracket squared. Square root of 2 in bracket squared. This squared outside, when you want to open this square root of 2 into 2 places, what is the answer? It's going to give you 2. That is the same that we have. Okay, so that is to say that 2 is equal to the square root of 2 in bracket squared. It's still the same thing. Let's go. It's equal to omega squared all over 2. So now, look at this left-hand side. The numerator and the denominator are having squared. So can we put it in one bracket and say it raised to the power of 2? Yes, it's still the same. So now, let's take this value in the right hand side to the left hand side. So when we take it to the left hand side, we are going to have minus omega squared all over 2 equal to 0. But you remember that this thing we just have now is just the what? The exponent. The power in equation 1. That is what we just solved. Okay? So that means the e raised to the power of minus x squared all over 2 minus I omega x dx that we have. So we picked the exponent and we simplified. Here is what we have. And then initially I told you what we wanted to do. We want to put x in one side and then see whatsoever we can factor out. If we can factor out the constant, here we factor out omega squared all over 2. Okay? So now bringing it back to the exponent where it came from, we are going to have 1 all over square root of 2 pi, the integral from negative infinity to positive infinity, e raised to the power of minus open bracket x plus I omega all over square root of 2 in bracket squared minus omega squared all over 2 dx. Alright? Yes. Now, let's split this into 2 now. It's still the same thing as saying, here we have 1 all over square root of 2 pi, the integral from negative infinity to positive infinity, e raised to the power of minus open bracket x plus I omega all over square root of 2 close bracket raised to the power of 2 times e raised to the power of minus omega squared all over 2 dx. Is that true? Yes. So now, here we have e raised to the power of minus omega squared all over 2. You see that it doesn't have x in it. So for that, it is a constant. So we take it behind the integral sign. So as it is going to meet the 1 all over square root of 2 pi, this is what we are going to have. We are going to have e raised to the power of minus omega squared all over 2 all over, this square root of 2 pi. We can split it into 2 also. So we are going to have square root of 2 times square root of pi. Alright, so we have the integral from negative infinity to positive infinity, e raised to the power of minus open bracket x plus I omega all over square root of 2 close bracket raised to the power of 2 dx. Let's call this equation 3. Okay, good. Again, let's evaluate let's find this integral. So for us to find this integral, we are going to use integration by substitution. Okay, so everything inside this bracket in the exponent, let's pick it and call it a letter. Okay, so let's call it letter u. We're going to say let u equal to x plus I omega all over square root of 2. Let it be called what? U. So we differentiate this u with respect to x. Now we apply the quotient rule. Okay, so applying the quotient rule, we are going to say that we have the u all over the x is equal to square root of 2 all over 2. Okay, yes. Now let's cross multiply. When you cross multiply, we're going to have 2 du is equal to square root of 2 dx. Okay, so here we want to make the x the subject. So we divide both sides by square root of 2. So when we do so, we are going to see that dx is equal to 2 all over square root of 2 du. Alright? Yes, in this equation 3, what do we have? We say that e raised to the power of minus omega squared all over 2 all over square root of 2 times square root of pi, the integral from negative infinity to positive infinity, e raised to the power of minus open bracket x plus I omega all over square root of 2 all the bracket raised to the power of 2 dx. This content in the bracket, we have replaced it, or we want to replace it with u. So what are we going to have? We are going to have e raised to the power of minus omega squared all over 2 square root of 2 times square root of pi, the integral from negative infinity to positive infinity, e raised to the power of minus we have u squared times 2 all over square root of 2 du. Hello? Yes. So what do? Here we have 2 all over square root of 2 is a constant. We take it also behind the integral sign. So we are going to have 2 all over square root of 2 times e raised to the power of minus omega squared all over 2 all over square root of 2 times square root of pi. The integral from negative infinity to positive infinity e raised to the power of minus u squared du. Okay? So in this case, in the denominator, this value outside the integral sign. Okay, so here we have square root of 2 times square root of 2 times square root of pi. So when you say square root of 2 times square root of 2, it's going to give you 2. Okay, and then we have 2 in our numerator, 2 in our denominator. Is going to cancel, right? Good. So here we are going to have e raised to the power of minus omega squared all over 2 all over square root of pi. The integral from negative infinity to positive infinity, e raised to the power of minus u squared. All right, du. Okay, good. So here, look at this. The integral from negative infinity to positive infinity, e raised to the power of minus x squared dx, is actually what we called Gauss error function. Okay, so for us to solve this, you can only solve using the help of a machine or a computer or a calculator. So the value is going to give us square root of pi. Okay, and then we say that this is called error function. Okay, Gauss error function. So now this integral from negative infinity to positive infinity, e raised to the power of minus u squared du, is giving us the error function. So the error function is also, this particular one gives us square root of pi. Okay, so the integral from negative infinity to positive infinity, e raised to the power of minus u squared du, is equal to square root of pi. So, initially we have e raised to the power of minus omega squared all over 2 all over square root of pi times the pi now. So the square root of pi, we cancel the square root of pi in the denominator. So we are going to be left with e raised to the power of minus omega squared all over 2. So therefore, the Fourier transform of the function f of x, which is equal to e raised to the power of minus x squared all over 2, is giving us e raised to the power of minus omega squared all over 2. All right? Yes. Thank you very much for watching. Please, I want you to gradually go through the video and listen attentively. All right? Please, if you are new to our YouTube channel, do us good by touching the subscribe button. Subscribe, like, share our videos, and stay blessed. Let's take more examples on Fourier transform.